My name is Chris Toft, and I mainly work on the drift detector, but I'm generally a facility scientist here at Boulby Underground Laboratory, and we're currently over a kilometre underground. That's over 3.5 Eiffel Towers, and we're down here to do, in this scenario, particle research. So this detector behind me is the drift detector. This is a directional dark matter detector. So dark matter is this set of elusive particles we have very little idea about, but we know from looking at the universe that something must be there. There's more there that we can actually see. So there's more mass in the universe than what we can see by just looking through a telescope. And we call this missing mass dark matter, and we think that this mass is made up of not big things but small things, in fact very small things, subatomic particles. And so we have to come to places like Boulby to run these incredibly sensitive dark matter detectors like drift. So drift is a directional detector, and that means that it's not just looking for an event to happen, but it's also trying to find out where that event came from. So not just trying to find a particle, but where did that particle come from, and that gives us additional clues about how to look for dark matter. So dark matter is weird, and the way it interacts with normal matter is also a bit unusual to human concepts. So when we say a dark matter detector like this, we're not capturing dark matter, we're not getting it in a big net and containing and analysing it. All we're seeing is its inference. So we're not even seeing the particle itself because of the way that it interacts. What we're actually seeing with a detector like drift is evidence that a particle was there at some point in time. So hopefully drift will experience a dark matter particle at some point in time, and when that does occur, it will interact in a certain way with the molecules inside the detector. And those molecules, because of the way that we've picked them and the way that we've set the conditions for them to be in, behave in such a way that they give us clues that there was a dark matter particle. So we don't ever really find dark matter, we're just seeing that it was there at some point. Its presence is inferred by what we can see. So science as a subject is interesting because when you look at the historical achievements of science, it's all been celebrating the great achievements, the great discoveries, the great positives. But what you don't often see is the great negatives as well. So the majority of science, a good 90-odd% of it, rough figures, are built on null hypotheses. So we had a theory and we set to thinking that it could be right, and ultimately we proved it wrong. And I guess to the layperson they would see that as a failure, but it's really not. The great thing about science is that when you prove something wrong, that's an achievement in itself. It's not that it's disappointing that you haven't found something, it's that you found something that's not correct, so you're now closer to finding what is correct. And the search for dark matter is just that. So we have a problem in physics, a very obvious problem that we have lots of facts about, but we don't as yet have a clear answer as to why this problem is occurring. So we have lots of different theories. We have one very prominent theory, the WIMP particle, that we think would solve all these answers, and it's just trying to find that WIMP theory to just make it fact. But even if we run these detectors for 10, 20 years, and eventually after all that time we see that there are no WIMP particles, it's not even close to the actual theory, that's still an achievement. So I don't feel that, although this is a great investment on my time, I don't feel like I'm wasting my time, even if I don't find anything, because no matter what I do here, I'm still contributing to the greater science effort. And just to be able to say that sentence is enough for me. To be able to be part of something so much bigger than me is a great driving force. Scientists are very imaginative, and some of the theories that they come up with can often feel aloof or totally unrealistic, but it's surprising how sensible their answers are. It's, again, to a layperson, when you approach these really weird concepts in science, quantum physics or weird spooky behavior, it just sounds like it's made up. But when you do you lay the foundations of physics or other sciences and you build up, you see that as every step of the way it just makes sense. And so when you get to crazy ideas like dark matter particles, there are billions of them everywhere and that they're surrounding galaxies and they're the reason that galaxies exist in the first place, it just sounds totally made up. But I really think that humans are able to solve these sort of crazy, weird problems, because it's not that we can't think of what the answer could be, it's just we can think of so many answers that we've got to try and pick which one's right. So I do believe that we can do this. It's just a matter of putting the time and the effort in to make it possible.